All right, let's dive in. Today, we're tackling AI agents, and we've got this awesome white paper from some Google AI experts to guide us.
It's a dense one, that's for sure, but packed with insights.
Yeah.
I'm really struck by how these AI agents are different. They can actually interact with the real world.
Yeah, it's not just processing language like we see with a lot of AI. This is about taking action, right?
Exactly.
Booking a flight, pulling data, even generating code based on what you ask it to do. That's some next level stuff.
It is, and it all comes down to how these agents are built. A generative AI agent, it's basically a large language model, but with the added ability to use tools to get things done.
So it's like a language model with a toolkit.
Yeah, that's a good way to think about it.
But how does that actually work? What's going on under the hood?
Well, imagine you've got a really skilled chef.
Okay, I'm following.
They know all sorts of recipes. They've got a pantry full of ingredients and then all the tools in the kitchen,
Right.
right? An AI agent is kind of like that. The language model is like the chef's brain. It understands the instructions and makes decisions. And then the tools, those are like the chef's utensils, the things that let them interact with the world around them.
So what kind of tools are we talking about here in the AI world?
Well, the paper breaks it down into three main categories. We've got extensions, functions, and then data stores. Each one has a different purpose, and they give the agent different ways to interact with systems outside of itself.
Okay, let's break those down a bit. What are extensions?
You can think of extensions like pre-built connections to external APIs,
Huh.
like ready-made modules for doing specific tasks. So you want your agent to book a flight, you could give it a Google Flights extension. That gives it direct access to the booking system.
So it's like plugging in a specialized skill set for the agent.
Yeah.
Very efficient. What about functions then? How do they differ from extensions?
Functions give developers more control over how the agent interacts with things outside of its own environment. So unlike extensions, which kind of run entirely within the agent's world, functions are executed on the client side.
You mean?
So the agent might suggest using a certain function, but then the actual execution of that function happens on the user's system.
Okay, so it's less about automation and more about collaboration in a way.
Exactly.
Yeah.
It's great for tasks that involve sensitive data or specific system configurations. The agent's giving guidance, but the user's still in control. Like, imagine the chef recommending a specific cooking technique,
I like where this is going.
but then the diner ultimately decides how to apply it to their own dish.
Right. That makes sense. And finally, what about data stores? What role do they play?
Data stores are all about giving the agent access to external knowledge.
Okay.
It's like giving our chef access to a huge library of cookbooks and culinary resources, right?
Yeah.
Data stores let the agent tap into a wide range of information sources, making its responses much richer and more informed.
Wow. So it's like giving the agent a whole internet's worth of information to draw from. That's incredible.
It's pretty powerful stuff.
This is already blowing my mind, and we haven't even gotten to the part about how the agent decides what to do with all this information and these tools.
Well, that's where the orchestration layer comes in. It's the brain behind the agent's decision-making process. It figures out how to prioritize information, pick the right tools, and actually execute actions to achieve its goals.
The orchestration layer, huh? That sounds like a whole other can of worms.
Oh, it definitely is.
Yes.
And there are a lot of interesting frameworks at play here. Things like React, Chain of Thought, Tree of Thoughts, they all offer different approaches to problem solving within the orchestration layer.
Okay, now we're getting into the real nitty-gritty. I'm ready to unpack those frameworks.
All right, well, let's start with React, which stands for Reason and Act. It basically guides the agent to think in a very step-by-step way,
Oh.
kind of like breaking down a complex task into smaller, more manageable chunks. The agent reasons about what to do next, considering the information and tools it has available, and then acts accordingly.
So it's all about a structured, methodical approach.
Exactly. And then we've got Chain of Thought, or COT, which focuses on really bringing out the agent's reasoning capabilities. It's like asking the agent to show its work so we can understand how it reached a particular conclusion.
Got it. Transparency is key, especially when we're talking about AI.
For sure. And then there's Tree of Thoughts, which takes things a step further. Instead of just thinking in a linear way, it allows the agent to explore multiple possible solutions simultaneously. Kind of like brainstorming different ideas before settling on the best one.
So it's a more exploratory approach, considering different paths to the goal.
Yeah, that's a good way to put it. It's particularly helpful for those really complex problems where there isn't one clear-cut solution.
That's fascinating. It seems like each framework has its own strengths and weaknesses. how do you decide which one to use?
Well, it really depends on the task and the complexity of the problem you're trying to solve. React might be great for straightforward stuff, but Tree of Thoughts might be more appropriate when you need deeper reasoning and exploration. And remember, these frameworks are constantly evolving, so it's a really exciting area to keep an eye on.
This is all incredibly insightful, but I want to make sure we connect this back to our listeners. Why should they care about AI agents? What's the big deal?
Well, I think AI agents represent a fundamental shift in how we interact with technology. They have the potential to become truly powerful collaborators, helping us automate tasks, make better decisions, and solve really complex problems in ways we never thought possible.
So it's not just about making things easier, it's about unlocking entirely new possibilities.
Exactly. And that's what makes this field so incredibly fascinating. We're still in the early stages of development, but the potential impact of AI agents is immense. We've talked about how they can interact with the real world, but I think it's helpful to dig into what really sets them apart from other kinds of AI that we might already be familiar with.
Yeah, it's easy to kind of lump all AI together, but this white paper does a good job of highlighting those key distinctions.
Totally agree.
They even have this chart comparing AI agents to traditional language models, which I thought was really helpful.
Yeah, that's a great visual.
And one of the things that really jumped out at me was the difference in how they handle information.
Right.
Traditional models are limited by whatever data they were trained on initially.
Like studying for a test from only one textbook. That's all the knowledge you've got.
Exactly. But an AI agent can actually go out and find new information. It's not limited to that initial data set.
Yeah, it's constantly expanding its knowledge base. It can connect to external systems, pull in data from the web, even access private databases if it needs to.
Wow. And that's all through those tools we talked about earlier, right? The extensions, functions, and data stores.
Exactly. It's like having the ability to instantly research any topic during that test.
That's a game changer. Is there anything else that stood out in that comparison for you?
Well, another big difference is how they handle conversation and context.
Okay.
Traditional language models often treat each query as a standalone request. They don't really have a memory of past interactions.
So if you ask a follow-up question, it's like starting a conversation with a complete stranger all over again.
Pretty much.
Right.
But AI agents, they have what's called managed session history. They remember the flow of the conversation, previous questions, even the actions they've taken already. And this allows them to give much more relevant and coherent responses.
Oh, that's so important. It's like the difference between chatting with someone who has amnesia versus someone who remembers your entire conversation history.
Exactly. And that persistent memory is crucial for tackling more complex multi-turn tasks, which is something that traditional language models really struggle with.
I see. I'm starting to get why people are so excited about the potential here.
It really goes way beyond just simple question answering.
Yeah. And to really understand that potential, I think we need to look at how these agents are actually built. And the white paper does a good job of diving into that orchestration layer that we touched on earlier.
Yeah, the orchestration layer, that's where all the magic happens.
This is the agent's brain, right? It decides how to use all those tools and information effectively. But can you break it down for me? How does that actually work?
Well, at its core, the orchestration layer is all about strategy and execution. We're talking about things like prompt engineering and different reasoning techniques.
Okay, those terms sound a little technical. Can you explain them in a way that makes sense, even if I'm not a programmer?
Sure. Think of prompt engineering as giving the agent very specific instructions and guidance on how to approach a task.
Okay.
It's like providing a recipe with very precise steps and techniques.
So it's not just about feeding the agent data. It's about teaching it how to think about that data.
Exactly. And then reasoning techniques. These are like giving the agent different mental tools to solve problems. The paper focuses on three main ones: React, Chain of Thought, and Tree of Thoughts.
Oh, right. We briefly touched on those earlier. Can we dive a little deeper into each one? I'd love to understand how they work.
Absolutely. Let's start with React, which stands for Reason and Act. It's basically a structured thought process where the agent is prompted to break down a complex task into smaller, more manageable steps.
So it's like a step-by-step methodical approach.
Exactly. The agent reasons about what to do next, taking into account the information and tools it has available, and then acts by taking the most logical step. And this cycle repeats until it achieves its goal.
Got it. It seems like a really efficient way to keep the agent focused and on track. What about chain of thought? What's that all about?
So chain of thought, or go-to-ne, it encourages the agent to explain its reasoning process step by step.
Oh, interesting.
It's kind of like asking the agent to show its work. And this not only helps us understand how the agent arrived at a particular conclusion, but it can actually improve the accuracy of its responses as well.
Oh, really? So forcing the agent to articulate its thought process actually makes it better at problem solving.
Exactly. It seems counterintuitive, but by making it express its logic out loud, so to speak, we can guide it towards more accurate, human-like reasoning.
That's fascinating. And finally, what about Tree of Thoughts? What makes that one stand out?
Well, with Tree of Thoughts, things get really interesting. Instead of a linear thought process like React or CoT, it allows the agent to explore multiple possibilities simultaneously, kind of like branching out in different directions.
So it's like the agent is brainstorming different solutions in parallel before settling on the best one.
That's a great analogy, and this is really helpful for those really complex tasks where there isn't one obvious solution. It allows for more strategic planning and looking ahead, almost like how a chess player might consider multiple moves in advance.
I see. So Tree of Thoughts would be ideal for those really complex problems where there's no clear-cut solution right away.
Exactly. And what's great is that these different reasoning techniques, they can be combined and customized depending on the specific task at hand. It's like having a whole toolbox of different problem-solving approaches.
Wow, that's amazing. And I remember the paper also mentioned something called cognitive architectures. How do those fit into all of this?
Ah, yes. Cognitive architectures, they provide a higher level framework for understanding how all these pieces fit together. The language model, the tools, the orchestration layer, it encompasses the agent's overall structure and function.
So it's like a blueprint for how the agent operates?
Yeah, exactly. And the paper uses a really cool analogy to explain this. They talk about a chef in a busy kitchen.
Oh, I love a good food analogy. Tell me more.
Okay, so imagine a chef who needs to prepare a meal for a customer. They take in information, like the order and what ingredients are available. Then they consider their own skills, the tools in the kitchen, and of course the desired outcome.
Okay, I'm picturing it.
Finally, they take action, they prepare the dish, they cook it, and all the while, they're constantly adjusting and refining their plan based on new information or feedback.
Right. And I can practically smell the delicious food. But how does this relate to AI agents?
Well, just like the chef, AI agents use cognitive architectures to achieve their goals.
Mm.
They take in information, reason about it, make decisions, and then take action using their available tools.
Okay, yeah,
And that orchestration layer that we've been talking about, that's like the head chef, coordinating all the different elements.
gotcha. So it's all about having a well-defined structure and process in place. But I think it's worth circling back to those tools themselves, those extensions, functions, and data stores. I'd love to get a clearer picture of how they actually work in practice.
Of course. And remember, those tools are what give the agent the ability to interact with the world beyond its initial training data. They're the key to its expanded capabilities.
Right. Okay, let's start with extensions. Can you give me a real-world example of how an extension might be used?
Sure, let's say you want to build an AI agent that can help you schedule appointments. You could use a Google Calendar extension. This would give the agent direct access to your calendar, so it could check your availability, add new appointments, even send out invitations.
So it's like having a super efficient personal assistant that manages your schedule for you.
Exactly. And that's just one example. There are extensions for all sorts of things, like sending emails, booking travel, controlling smart home devices, you name it.
Okay, that's super cool. I'm starting to see how extensions can really broaden an agent's capabilities. What about functions then? How do those differ in practice?
Well, functions offer more flexibility and control for developers. Remember, they are executed on the client side, which means they can access and manipulate data or systems that are external to the agent's own environment.
Can you give me a concrete example of that? I'm still a bit fuzzy on the distinction between extensions and functions.
Sure, let's imagine you're building an agent that needs to analyze financial data from your company's internal database. You could create a function that allows the agent to query that database, but the actual execution of that query happens on your company's servers, not within the agent itself.
So it's kind of like the agent is making a request for data, but the client, in this case your company, still retains full control over how that request is handled.
Exactly. And this gives developers a lot of flexibility in terms of security and privacy. They can control exactly how the agent interacts with their systems and what data it has access to.
That makes a lot of sense. It's a good way to balance the power of AI agents with the need for data security and control.
Exactly.
And finally, what about data stores? Can you give me an example of how they might be used in the real world?
Sure. Data stores are all about empowering agents with external knowledge. Think of them like huge libraries of information that the agent can tap into and process. And one of the most exciting applications here is something called retrieval augmented generation, or RAG for short.
RAG. That rings a bell. Can you remind me what that is?
Oh yeah, RAG is a really powerful technique that combines the reasoning abilities of language models with the vast knowledge stored in these external databases. So imagine you have a huge collection of documents, research papers, maybe even code repositories.
Okay.
RAG allows the agent to actually search through that information, retrieve the most relevant bits, and then use that to generate much more informed and accurate responses.
So it's like giving the agent access to a super-powered research assistant that can instantly pull up any relevant information from a massive library of knowledge.
Yeah, that's a great way to put it. And RAG is a game changer for tasks that require really deep domain expertise or access to lots of information. This is impressive. But how does an agent actually learn to use all these tools effectively?
That's where targeted learning comes in.
Targeted learning.
Yeah, we're talking about three main approaches: in-context learning, retrieval-based in-context learning, and fine-tuning-based learning.
Okay, slow down there for a second. That's a lot of learning styles. Can we break those down one by one? What's in-context learning?
Well, think of it like giving someone a recipe, some ingredients, and some basic cooking techniques. They figure it out as they go, learning in the moment.
So it's like on-the-job training for AI.
Exactly.
Okay, what about retrieval-based in-context learning? Is that similar?
It is, but with added resources. Imagine giving that same person access to a massive pantry and a library of cookbooks. They can find anything they need to enhance their dish.
I like it. More resources, more possibilities. And finally, there's fine-tuning based learning. What's that all about?
Well, that's like sending our chef to culinary school to master a specific cuisine. It's deep, focused training for specific expertise.
All right. So in context is learning on the fly, retrieval based, is learning with extra resources, and fine-tuning is specialized training. By combining these methods, we're essentially creating AI agents that are super versatile and adaptable.
Precisely. Just like a chef who can whip up anything from a simple omelet to a five-course meal, an agent with diverse training can tackle a huge range of tasks. But even the most talented chefs need the right tools and kitchens to excel.
Ooh, I like where this is going. You're saying there are platforms and libraries that help us build these amazing AI agents, something like a digital kitchen for cooking up AI magic.
Exactly. Think of open source libraries like LangChain as the ultimate AI kitchen. They provide all the tools and ingredients you need to build your own custom agents.
So it's like a digital recipe book guiding us through the process of creating these AI masterpieces. But how do developers actually build these agents? Where do they even begin with all these different tools and techniques?
That's where those open source libraries like LangChain really shine. They provide a framework for building custom agents, letting developers chain together different components like language models, prompts, tools, and reasoning mechanisms.
So it's like building with Lego blocks. But for AI, you can mix and match different pieces to create something truly unique. But building with Legos can be tricky, especially for beginners. Is it the same with building agents? Or can anyone give it a try?
Well, the beauty of open source is that it's designed to be accessible. If you have some programming experience and a willingness to learn, you can definitely dive in and start experimenting.
That's encouraging. So even if you're not a seasoned AI expert, you can still explore this exciting world and maybe even build your own helpful agents. But what about for organizations or companies that want to deploy these agents at scale? Are they stuck building everything from scratch?
Not at all. Platforms like Google's Vertex AI provide a more robust and managed solution for building, deploying, and managing production-grade agent applications.
So they're like going from building with Legos to having a professional construction crew at your disposal. Get the same impressive results, but with more support and expertise.
Exactly. Vertex AI handles all the complex infrastructure and backend details, allowing developers to focus on designing and refining their agents' behavior and capabilities. It's a powerful tool for bringing these incredible AI agents to life and integrating them into real-world applications.
This is all incredibly mind-blowing. It feels like we're witnessing a revolution in AI where these intelligent agents are poised to change the way we live and work. From tackling complex problems to streamlining daily tasks, the possibilities seem endless.
I completely agree. And we're just scratching the surface of what's possible. As these agents continue to evolve, we can expect even more groundbreaking advancements, pushing the boundaries of AI and its impact on our world. It's been an incredible journey, and we're just getting started.
So keep those minds curious. Keep exploring. And who knows, maybe you'll be the one building the next generation of these amazing AI agents. Thanks for joining us, and until next time, keep asking those big questions.